Longitude and time. Here's our Earth rotating at a speed of 1,000 miles per hour at the equator. Up to this point, you've been lied to. The Earth does not complete one rotation in 24 hours. It actually takes less time. One complete rotation takes 23 hours, 56 minutes, and 4 seconds. That's one full rotation. The Earth is rotating from west to east, and it always moves in that direction. So because of that, it appears that the sun rises in the east and appears that the sun will set in the west. We're here to talk about how longitude is really related to time. And so because the Earth completes a 360-degree rotation in about 24 hours, that works out to about a 15-degree movement per hour. So after 24 hours, it has completed a 360-degree rotation. So the lines of longitude were created to mark off 15-degree intervals. So each line of longitude represents a time zone because it is a marker of 15 degrees from the next line of longitude, which is equivalent to each hour in the Earth's rotation. Let's take a look at it from space. So we're looking at it as if the sun and the Earth were the only two objects in our solar system. And this is not to scale. The Earth is actually much further away from the sun than it appears here. But I want to point out an important relationship. The sun can only shine on one half of the Earth at the time, because only one half can be facing the sun. So if I were to look at the Earth up close, half of it would be experiencing dark and half of it would be experiencing light. We call that division the terminator, and that terminator is a dividing line between night and day. So if you were on Earth and you were here, assuming that the Earth is rotating in this general direction, right? Say the Earth is rotating like this, a location over here is experiencing daytime, so as the Earth rotates this way, we're getting closer and closer to night. So this position is something like dusk, when the sun is low in the sky right before it becomes nighttime. And if I were to follow this movement and come around to this side, this would be dawn, when the sun's about to rise. The edge on the terminator line represents, in one location, the setting of the sun, in another location, the rising of the sun. What we'll do is we'll apply a regular clock to the rotation of the Earth. So on my regular clock, I've marked off 12 p.m., 6 p.m., 12 a.m., and 6 a.m. And I've added this dot, and that dot represents a location that we're going to track. We're going to track it as it moves throughout the day. So right now, this white dot is in line with 12 p.m. That means that it's receiving sunlight. It's noon. It's the middle of the day. So if we were to follow that dot as it travels, we can see it's turning away from 12 p.m. and getting closer to 6 p.m. So now it's experiencing night hours. It's in the darker part. And at this point, it is 12 hours away from where it was before, which was noon. And it moved at a rate of 15 degrees every hour. So after 180 degrees, it's made a 12-hour time difference. If I continue, if I move this forward, now our white dot is approaching 6 a.m., so it's going to see the sun rise. The sun rises. Now it's 7, 8 a.m., 9 a.m., 10 a.m., 11 a.m., 12 p.m., back to where we started, one full rotation. And every increment that it shifted was equivalent to 15 degrees, but it's also equivalent to 1 hour. There are 24 time zones that are related to the 24 major lines of longitude. The United States, for example, has 4 time zones associated with it. Those are the Eastern Standard Time, which we're in, the Central Standard Time, which is west of us, Mountain Standard Time, which is further west, and then the Pacific Standard Time, which is even further west. So those are 4 different time zones that are represented by 4 different major lines of longitude. 75 degrees west, 90 degrees west, 105 degrees west, and 120 degrees west. So as you travel west across the United States, you actually go back in time. You go to earlier and earlier time. So for timekeeping purposes, Greenwich Mean Time is the starting time zone. That's time 0. That runs right through Greenwich, England. All time zones are either plus or minus hours from that point. So as you travel west, away from the prime meridian, time's going to get earlier. As you travel east from the prime meridian, time's going to get later. That's because the sun is rising in the east. And as the Earth rotates in that direction from west to east, locations that are east of the prime meridian are experiencing the day sooner. Longitude was created based upon the 24-hour daily rotation of the Earth, and time zones were created from those lines of longitude to better keep track of moving across the Earth. So that's it for now. Thanks for watching.